The night comes down heavy over the Norman coast on the 19th of June 1944. For 13 days, the beaches of Calvados have been Allied ground. The dead have been buried in shallow provisional graves above the high water mark. The cliffs at Pointe du Hoc, still smoking in memory, have been walked over by staff officers with clipboards. Landing craft come and go in a rhythm that already resembles the industry of a working port. And offshore, in water no deeper than a country lane, a miracle of engineering rides at anchor. An entire artificial harbour floated across the channel, piece by piece, and sunk into place in the days after the landings, its concrete caissons standing like the teeth of some monstrous drowned jaw around the anchorage off Omaha Beach. The wind begins around midday. It comes not from the west, where the summer weather usually moves, but from the northeast, blowing straight down the funnel of the channel and straight into the exposed Calvados shore. By evening, the anemometers on the ships are reading gale force. By the following morning, the 20th, the sea has risen into something the crews of the old merchantman scuttled as breakwaters have never seen in June in their lives. Waves 8 feet high, then 10, then higher, march in unbroken ranks against the Phoenix caissons. Great hollow boxes of reinforced concrete, each the size of a 5-story building, each weighing as much as a small warship. The bombardons, the floating steel breakwaters shaped like enormous crucifixes moored a mile offshore, are wrenched at their cables and begin to break their moorings one by one. The whales, the flexible steel roadways that carry trucks from the piers to the shore, buckle and snap as the swell drives beneath them. Landing craft, hundreds of them, tank landing ships and infantry landing craft and the little Higgins boats, are torn from their moorings and driven ashore in a tangled scree of metal that will, in places, be 40 vessels deep. The storm blows for 3 days. When it lifts on the 22nd, Mulberry A, the American artificial harbour off Omaha Beach, no longer exists as a functioning port. Its Phoenix caissons are cracked, tipped, hollowed out, some of them split cleanly along their reinforcement seams. Its roadways are so much floating scrap. The channel between the outer breakwater and the inner pier is choked with the wrecks of the boats it was built to serve. The engineers who walk out along what remains of the piers, in oilskins still wet from the last of the wind, count the damage and do not quite believe what they are seeing. In the space of 72 hours, weather has done to the invasion supply spine what 6 weeks of German artillery, aircraft and coastal guns did not manage to do in the run-up to the landings. The judgment, when it is finally written down, will come from the United States Navy itself, in the official record of its Naval History and Heritage Command. The storm, that record says, in language stripped of all flourish, succeeded in doing what the Germans had not been able to do: destroy the great Mulberry artificial harbours. There is a certain flatness to the phrasing, the flatness of a service used to writing epitaphs. But read it slowly, and it becomes one of the most remarkable sentences produced by the entire war. The Wehrmacht had failed, the weather had not. Along the coast to the east, in the British sector at Arromanches, the second harbour, Mulberry B, has fared better. The wave angles at Arromanches are different, running more obliquely to the shore. Offshore sandbanks break the worst of the swell before it reaches the outer caissons. When the wind falls, Mulberry B is battered, its outer line breached in places, its inner roadways bent, but it is still standing, and still, in the engineer's language, savable. Over the following days, salvage crews will move down the coast from the American sector to the British, carrying with them whatever pieces of Mulberry A can be pried loose and towed. Phoenix caissons intended for the American harbour are resunk into the British breakwater. Sections of whale roadway are cannibalised and rewelded into service at Arromanches. Out of the wreck of one harbour a second is reinforced, and it is this reinforced Mulberry B at Arromanches that will go on to serve the Allied armies in northwest Europe for the next 8 months, offloading between 7,000 and 9,000 tons of supplies every day, until the capture of Antwerp in the late autumn opens a real deep-water port, and the artificial harbour can be politely retired. That is the record. That is what the storm of June 19th actually did to a beachhead that had already been in Allied hands for 2 weeks. It smashed one of the 2 purpose-built harbours of the greatest amphibious operation in history, and came within a wave or 2 of smashing the other. It did this to caissons weighing 6,000 tons apiece. It did this to a beach that was, by then, no longer a beach in any tactical sense, but a working military port defended by artillery on the ridges above it, and by fighter cover patrolling the sky overhead. Hold that image. Hold the picture of the concrete boxes cracking open, the roadways folding, the landing craft driven ashore in stacks, and now ask the question that this documentary exists to ask. What if Eisenhower had still been crossing when it arrived? What if the fleet, 7,000 vessels, 156,000 men, the tanks and the trucks and the rations and the radios and the surgeons and the chaplains, had been not 2 weeks ashore on the 19th of June, but only hours into its crossing, or hours into its landing, when that same storm came down the channel from the northeast? The June 19th storm is not a hypothesis. It happened. Its damage is catalogued in the records of the Imperial War Museums, in the reanalyses of the European Centre for Medium-Range Weather Forecasts, in the official Navy histories of two nations. It is one of the few pieces of counterfactual raw material a historian could ever ask for. A storm of documented catastrophic power, arriving on a date that is not chosen by a novelist but fixed by the astronomy of the tides and the phases of the moon. The question of what a June 19th invasion would have looked like is, uniquely, a question that history has partially answered in advance. To understand why the date matters, and why the storm and the invasion window are yoked together by more than coincidence, one has to begin somewhere quieter than a channel gale. One has to begin in the map room at Southwick House, in the low hills behind Portsmouth, in the last days of May and the first days of June 1944, where a single man carries a decision that no committee can share and no order from above can lift from him. The house is a white Regency mansion requisitioned by the Royal Navy and turned over, in the spring of 1944, to Supreme Headquarters, Allied Expeditionary Force. In its ground floor library, the panelling has been stripped back, and a wall-sized map of the southern coast of England and the northern coast of France has been erected, its counters and its coloured pins tracking the assembly of the largest invasion fleet ever gathered. The map is worked, day and night, by two carpenters from a toy company in London who are quietly conscripted for the task, and who have signed the Official Secrets Act 3 times over. In front of that map, in the last week of May, Dwight David Eisenhower, 53 years old, a soldier of the American Great Plains, a man who has never commanded troops in combat until 18 months earlier, and who now commands more of them than any American in history. He walks and paces and smokes and waits. Around him, staged along the southern coast of England from Falmouth to Felixstowe, is Operation Overlord. The numbers, even 80 years later, resist comfortable comprehension. 156,000 men are to land on the first day, delivered by roughly 5,000 ships of every conceivable class, from battleships of the line down to plywood landing craft with outboard motors. 11,000 aircraft are to fly in support, from 4-engined heavy bombers scheduled to saturate the coastal batteries at dawn down to the little Piper Cubs of the artillery spotters. 3 airborne divisions are to drop behind the beaches in the hours before the seaborne landings, to seize the causeways and the bridges, and to hold them against counterattack until the men from the sea can arrive. In the marshalling areas of Dorset and Hampshire, entire divisions are already sealed behind barbed wire. Their men issued franks and phrase books. Their vehicles waterproofed for the wade off the ramps. The country roads of southern England are choked, from hedge to hedge, with tanks parked bumper to bumper for miles at a time. There is, in the phrase of one American officer, no more room in England. The island itself is, by the end of May, listing to the south under the weight of what has been assembled on it. All of this is Eisenhower's. All of it waits on his word, and his word in turn waits on the weather. The Overlord planners had understood from the beginning that the invasion could not be launched on any date its commanders might choose. It could be launched only within an extremely narrow set of dates each month, dates defined not by strategy, but by astronomy. The airborne divisions needed moonlight for their drop, late-rising moonlight, so that the transports could cross the channel in darkness, but the paratroopers could see the drop zones in silver. The seaborne divisions needed a low tide at dawn, so that the German beach obstacles, the steel hedgehogs, the wooden ramps tipped with telemines, the concrete tetrahedra known as Belgian gates, would be exposed above the water and could be cleared by combat engineers before the main waves came in. The two requirements, moonlight and low dawn tide, had to fall within days of one another, and even then they had to fall in weather that would let the fleet cross 100 miles of open water without foundering and let the aircraft find their drop zones. Once those constraints were laid out on the calendar, the viable dates in any given month collapsed to a handful. In May 1944, there had been a window. It had been passed over for the sake of a few more weeks of training and equipment. In June, there was another, the 5th, the 6th, and the 7th. After the 7th, the moon would rise too early and the tides would run too high, and the invasion would have to wait. Wait, in fact, for very nearly a fortnight. The next combination of the right moon and the right dawn tide would not come around again until the 19th of June, the same date that history would, in the actual event, mark with a storm of once-in-a-generation ferocity. That coincidence is the pivot on which this documentary turns, and it is a coincidence written into the mechanics of the solar system and the geography of the channel long before any weatherman thought to look at a barometer. The man responsible for looking at the barometer and for translating what he saw there into a recommendation on which 150,000 lives depended was a lean, precise, Scottish meteorologist by the name of James Martin Stagg. He was 43 years old in the spring of 1944, tall and slightly stooped, with the careful voice of a scientist who has been trained not to say more than his data will bear. Before the war, he had been superintendent of Kew Observatory, one of the oldest scientific institutions in Britain. He had led a magnetic survey expedition to the Canadian Arctic. He was not a soldier. He wore the uniform of a group captain in the Royal Air Force, but he had never flown a combat sortie and never would. He had been appointed in November 1943 to a job that had not existed before, Chief Meteorological Advisor to the Supreme Allied Commander. His task was to reconcile the forecasts of 3 competing weather services, the British Meteorological Office, the United States Army Air Force's Meteorology Unit, and the Royal Navy's own forecasters, into a single recommendation that Eisenhower could act upon. The 3 services did not, as a rule, agree. British forecasting in 1944 leaned on empirical chart-based methods, refined over decades of North Atlantic experience, in which men who had spent their working lives reading the pressure patterns off Iceland and the Azores made intuitive judgments about how those patterns would evolve. The American service, younger and more mathematical, favoured the newer analytical techniques then emerging from Scandinavian meteorology, with its polar fronts and its air mass analysis. The Navy forecasters brought a third perspective, weighted towards sea state and wind at the surface. In quiet weather, these methods converged on much the same answer. In unsettled weather, of the kind that dominates the North Atlantic in every season, they could diverge sharply, and it fell to Stagg to stand between them and speak, in a single voice, to a general who needed a single answer. He did the job from a small office at Southwark, with a direct line to the Admiralty's central forecasting room and a habit of poring over charts late into the night. His team met twice a day, sometimes more, in a room with its own wall-sized map, and argued out their differences under his chairmanship. When they had agreed, or, more often, when Stagg had decided which of their disagreements he was prepared to bet the invasion on, he would carry the result upstairs to Eisenhower's briefing, where the Supreme Commander and his air, land and sea deputies waited. He would be asked to reduce a fluid, 3-dimensional forecast to a yes or a no. He would give it. He would be believed, or he would be argued with, and then he would go back down to the map room and start again. Stagg understood, better than anyone in the building, what the calendar looked like beyond the June 5-7 window. He understood that if the weather closed the door on those 3 days, the door would not open again for very nearly 2 weeks. He had said as much, in as many words, to Eisenhower and to the chef staff. A postponement past the 7th of June was not a postponement of a few days. It was a postponement to the 19th, at the earliest, and possibly beyond. And the men in the marshalling areas, the men sealed behind their barbed wire with their franks and their phrase books, could not sit in those areas for another 2 weeks without the entire secret of the operation seeping out of them like water out of a sieve. Weather, geography and human endurance had all collaborated to make the June 5-7 window less a choice than a summons. At the end of May, the forecast had looked good. A ridge of high pressure sat over the western approaches, and the long-range charts suggested that early June might open in settled weather, warm, dry and calm. In the first days of June, that picture began to crack. A deep depression, one of the Atlantic's ordinary summer visitors, appeared off the coast of Newfoundland and began to track east, faster and stronger than the forecasters had expected. A second, following it, promised to prolong the disturbance. By the evening of the 3rd of June, the outlook for the 5th had darkened enough that Stagg was preparing his staff for the possibility that they would have to advise a postponement. On the morning of the 4th, at 4:15, in a meeting whose minutes have been reconstructed from the recollections of half a dozen participants, he advised exactly that. Winds on the channel would be too high. Cloud over the beaches would be too low for the airmen. The surf on the landing sectors would be too heavy for the smaller craft. He could not, in conscience, recommend that the operation proceed on the 5th. Eisenhower listened, asked a few short questions, polled his commanders, and postponed. Convoys already at sea, some of them from as far away as Belfast Lough and the Scottish Firths, were signalled to turn back or heave to. The great gears of the operation ground down and then reversed. Somewhere in the middle of the channel, the tow trains carrying the first components of the Mulberry harbours, the long, low, ugly Phoenix caissons under the tow of tugs and salvage vessels, were also halted, their crews riding out the weather in place because there was no time in the schedule to send them back and start again. Even that single day of postponement, later chroniclers would note, was enough to freeze the entire logistics chain in mid-stride, a demonstration, before the invasion had even happened, of how tightly Overlord's mechanism was wound to a 24-hour tolerance. On the evening of the 4th, Stagg convened his team again. What they were now looking for, in the shifting patterns on their charts, was a gap, a narrow interval in the incoming weather within which the operation might yet be threaded, and remarkably they thought they saw one. Behind the depression currently sweeping across the channel, a small transient ridge of higher pressure appeared to be building. If it arrived when their model suggested it would deliver on the 6th of June a window of perhaps 36 hours in which winds would drop, cloud would lift enough for the airmen to work, and surf would fall to something the landing craft could survive. Not calm, not the settled sunshine that Overlord's planners had imagined the previous winter, but possible. Marginal, but possible. At 9:30 on the evening of the 4th, in the mess room at Southwick, Stagg carried that forecast up to Eisenhower and his commanders. A wind was already rattling the windows of the house, the front edge of the same system whose passage he was now betting on. He described the gap. He was, as always, careful. He did not promise fair weather. He described marginal conditions, a limited window, and the risk that the next system behind it might close the gap earlier than his chart suggested. He was asked by each of the deputies in turn what he thought. He gave his best judgment. Then he withdrew. What Eisenhower said next and how long he took to say it has been reconstructed in 100 memoirs and remains, in its essentials, extraordinary. He walked, he smoked. He asked each commander in the room for a recommendation. Montgomery was for going. Ramsay, the naval commander, thought the fleet could manage it. Lee Mallory, the airman, was doubtful about the air cover. Tedder, his deputy, was cautious. Around the room, the votes and half-votes were tallied silently by everyone present, and none of them meant anything, because the decision was Eisenhower's alone. He turned it over, and then, in a phrase that has become almost too famous to hear properly, he said, "I am quite positive we must give the order. I don't like it, but there it is." At 4:15, on the morning of the 5th, Stagg confirmed the forecast one more time. The gap was still there. The ridge was still building. Eisenhower confirmed the order. The convoys, which had been recalled or held less than 24 hours earlier, were signalled to sail again. Across the harbours of southern England, the anchors came up, and the greatest fleet ever assembled began to move south into a sea already going down from the previous day's gale. The June 5-7 window had closed to a single date, the 6th, and beyond the 6th, in the calendar of tides and moons and pressures, there was only one other place the invasion could go, the 19th. Stagg knew it. Eisenhower knew it. Every senior officer in the room at Southwick that night knew it. If the 6th went badly, if the forecast failed, if the landings were repulsed, if the weather closed in before the beachhead could be consolidated, the next attempt would come almost 2 weeks later, into a weather system nobody in that room could yet see, over a coastline that in the meantime would have received 2 more weeks of German reinforcement. It is the choice of that date, and the storm that in the actual event chose it back, that gives the counterfactual its bite. History does not usually leave counterfactual historians such tidy raw material to work with. It does not usually stage, 2 weeks after a decision, the exact catastrophe that the decision was made to avoid, and stage it against structures more solid, in some ways, than the ships and men who would have met it a fortnight earlier. But that is precisely what history did in June of 1944. On the 5th, Stagg found his gap. On the 6th, Eisenhower's men went ashore, and on the 19th, into an established beachhead defended by artillery and covered by the Royal Air Force, the storm arrived that would break the concrete of Mulberry A into so many pieces that no engineer could put them back together. The distance between those 2 dates is 13 days. 13 days of unloading, 13 days of digging in, 13 days of hauling anti-aircraft guns up onto the bluffs above Omaha and running telephone wire through the hedgerows of the Cottonton. 13 days that separated a beachhead from a fleet in the water. 13 days that Stagg's forecast and Eisenhower's decision bought and paid for on the night of the 4th of June. To understand what those 13 days were worth, one has to look, first, at what happened in the hours before Stagg walked into that room. One has to look at the weather itself, at the front rolling in off the Atlantic on the night of the 4th into the morning of the 5th, at the way the wind moved over the channel, and the way the pressure fell and rose at the science, still young in 1944, that let a small team of men in a Regency house near Portsmouth see a gap that the German meteorologists on the other side of the water did not see at all. The night of the 4th of June at Southwick House did not feel like history in the making. It felt like a house full of tired men waiting for a barometer to move. The library where the conferences were held had been fitted out with a large situation map along one wall, a coloured chart of the southern coast of England and the northern coast of France, pinned and repinned as the fleet moved and the fronts shifted, and around that map, in the low light of shaded lamps, the senior commanders of the Allied Expeditionary Force gathered twice a day to hear the same small Scottish meteorologist tell them what the sky was going to do. Outside, the weather had already turned. The wind that had built through the afternoon of the 4th was coming in off the Atlantic in gusts strong enough to rattle the sash windows on the south side of the house. Rain was moving in bands across Hampshire, heavy enough at times to blur the outline of the trees on the lawn. In Portsmouth Harbour, a few miles to the south, the ships that had not already sailed were rocking hard against their moorings, and the ones that had already sailed, the slower convoys, the tank landing craft, the tugs hauling components of Mulberry, were somewhere out in the channel, riding the same weather, waiting for orders they had not yet received. Inside the library, Eisenhower sat in a chair set slightly apart from the others. He was in his service jacket, the 4 stars visible on each shoulder, and he was smoking. He had been smoking, by most accounts, at a rate that alarmed the officers around him. 4 packs of Camels a day in the final week before the landings, and the ashtrays in the library and in his personal trailer at the nearby camp were filling as fast as his aides could empty them. His face, in the photographs taken in those days, has the drawn, hollow look of a man who has not properly slept in weeks, and who is running now on coffee and nicotine, and the flat, disciplined calm that his subordinates would remember for the rest of their lives. Around him sat the men whose armies and fleets and air forces would carry the order out. Montgomery, commanding the ground forces of the invasion, in his usual grey pullover and corduroy trousers, upright and clipped and impatient with delay. Ramsay, the naval commander-in-chief, whose ships were already at sea and whose face carried the particular weariness of an admiral, whose plans depend on tides that will not wait. Lee Mallory, commanding the tactical air forces, whose aircraft needed cloud ceilings and visibility that the current forecast did not offer. Tedder, Eisenhower's deputy, thoughtful and slow to commit. Bedell Smith, the chief of staff who tended to speak last and whose judgment Eisenhower trusted almost as his own. Into that room, at just before 9:30 on the evening of the 4th, walked Group Captain James Stagg. He was in RAF blue, tall and thin, with the diffident, careful manner of a career civil servant in uniform, and he carried a set of hand-drawn charts prepared with his team in the map room upstairs. He set them out on the table by the window and began, in the flat cadence of a man who has learned to keep his emotion out of his voice, to describe the weather that was coming. A deep Atlantic depression, he said, was tracking east across the ocean toward the western approaches of the channel. A cold front associated with it was already crossing the invasion area. Behind that front, the forecast for the 5th of June, the following day, the day the landings were scheduled to begin, was for force 5 winds in the channel, low cloud with bases below 1,000 feet, and heavy sea states that would rise through the morning. The visibility for the airborne drops would be poor. The visibility for the naval bombardment spotters would be worse. The cloud base would prevent effective use of the medium bombers on the coastal batteries. The seas would swamp the smaller landing craft before they reached the beaches. There was a long silence. Ramsay looked at his hands. Lee Mallory shook his head slowly. Montgomery, characteristically, wanted to go anyway. Eisenhower asked questions. Quiet, precise questions about the confidence in the forecast, about the possibility that the front might pass through more quickly than expected, about what the American forecasters at Wide Wing were saying, and what the naval team under Instructor Commander Hogben thought. Stagg answered each of them evenly. There were disagreements within his team, he said. There were always disagreements, but the consensus was firm enough. The 5th was not viable. Eisenhower gave the order to postpone by 24 hours. That order, spoken in a room the size of a comfortable drawing room in a Regency house on the Hampshire Downs, then travelled outward, in the space of the next several hours, along the entire nervous system of the largest amphibious operation ever attempted. Signalmen in the wireless room at Southwick tapped it out to Ramsay's naval command at Portsmouth. From Portsmouth, it went to the naval control stations along the whole southern coast of England, from Falmouth in the west to New Haven in the east. From those stations it went out over the marine bands to every convoy at sea, to every port and harbour and river mouth where ships were still waiting to sail, to the airborne divisions in their camps at Greenham Common and North Witham and Cottesmore, to the paratroopers already blacked up and buckled into their harnesses, waiting to board the C-47s, to the divisional headquarters of every formation slated to embark on the 5th, to the shipping officers holding the loading manifests, to the beachmaster teams already briefed for landing, to the medical units, to the ammunition dumps, to the fuel depots, to the field bakeries. The message that went out was short. The invasion was postponed by 1 day. New H-hour would be issued in due course. Ships already at sea were to reverse course and return to their embarkation points. That last order, the recall of ships already at sea, is where the real cost of even a 1-day postponement showed itself, and where the counterfactual begins to sharpen. Some of the slower convoys had sailed as early as the 3rd of June. They were the components that could not accelerate, the tugs hauling concrete caissons at 3 or 4 knots across a channel already turning ugly, the LCTs carrying tanks and vehicles that took hours to form up into their assigned columns, and hours more to disperse and reform. When the recall order reached them, they were already well out into the channel, in some cases within sight of the French coast on the far horizon. They turned. In gale force winds and a rising sea, in the middle of the night on the 4th into the 5th, several thousand vessels executed one of the more remarkable maritime manoeuvres of the war. A mass, coordinated reversal, in weather that no peacetime commander would have accepted without lights, without radio chatter beyond what was strictly necessary, without collisions serious enough to compromise the schedule. Some of them, in the confusion, could not be reached in time and had to be shepherded back by fast escorts sent out from Portsmouth and Portland. Some of them, having reversed, then had to reverse again the following night when the order came to sail once more. The crews of those ships, men who had been briefed and rebriefed, keyed up for landing, sealed aboard for days already, spent 48 extra hours in cramped, heaving, unlit holds, being sick into buckets, waiting for a war they had already once been told was about to begin. Among the vessels caught in that reversal were the tugs and towing groups hauling components of the Mulberry harbours. The great concrete Phoenix caissons, some of them displacing over 6,000 tons, were being moved across the channel on the timetable of the invasion itself, designed to arrive off the Normandy coast within days of the first landing so that construction could begin under the shelter of the beachhead. The postponement disrupted that timetable at every level. Tows had to be shortened, held mid-channel, in some cases turned about. The whole delicate choreography of when a particular caisson would arrive, at which point off which beach, sequenced against the arrival of the block ships and the outer breakwater, had to be revised on the fly by staff officers working over marked-up plotting sheets in the operations room at Southwick. None of this was catastrophic. Ramsay's staff had planned for the possibility of a 24-hour hold, and the plan absorbed the shock, but it absorbed it at a cost, a cost measured in crew exhaustion, in fuel burned unproductively, in wear on tugs and towing gear, in the erosion of the fine timing that the whole operation depended on. A 24-hour postponement was survivable. A 48-hour postponement would have been harder. A postponement of 13 days into the next tidal window would have required the entire fleet to disembark, disperse, and reassemble, men off ships, ships back to their ports of loading, and the whole operation, with all its secrecy, held on the edge of a knife for 2 more weeks. That was the shadow that hung over the room at Southwick on the night of the 4th, not the discomfort of a day's delay, the near impossibility of a fortnight of it. The commanders dispersed to their quarters in the small hours of the 5th. Eisenhower went back to his trailer at the camp near Southwick and lay down without undressing. He did not sleep. At around 3:30 in the morning he was up again, walking outside, and by all accounts the weather at that moment was doing something like the opposite of what any of them expected. The rain had stopped. The wind was still strong, still gusting hard through the trees, but the sky over Portsmouth had begun to clear in patches, and between the ragged edges of the retreating cloud, a few stars were visible. The Atlantic front had come through faster than the forecast had feared. Somewhere behind it, Stagg's team believed and had said so cautiously the previous evening, a ridge of higher pressure was building, and behind the ridge another front was coming, but between the two, for a brief window, the weather in the Channel would ease. At 4:15 on the morning of the 5th of June, the commanders reassembled in the library at Southwick House. Stagg came in again with a new set of charts. The night's observations from the weather ships in the Atlantic, from the reconnaissance aircraft flying out over the ocean, from the reporting stations in Iceland and Greenland and the Faroes, had refined the forecast. The clearing, Stagg said, was real. It would begin to reach the Channel later on the 5th and hold through most of the 6th. Winds would drop to force 3 or 4. Cloud bases would rise. Visibility would improve enough for the airborne drops, and for the spotters directing the naval guns. There would still be swell, the sea does not settle as quickly as the air, but the swell would be within the operational limits of the landing craft. Then he said what everyone in the room already knew and needed to hear him say anyway. The window was narrow, perhaps 36 hours. Beyond it, another front would move in, and conditions would deteriorate again. Whether the deterioration would be severe or moderate, he could not yet say. What he could say was that if the invasion went on the 6th, the first day of landings, the airborne assault, the initial naval bombardment, the first waves ashore, would all take place inside that window. What happened after that? The reinforcement, the build-up, the arrival of follow-on divisions, would happen in progressively worse conditions. Eisenhower listened. He asked the same questions he had asked the night before. The confidence, the disagreements within the team, the naval and air commanders' assessments. Ramsey said the Navy could sail. Lee Mallory said the Air Forces could cautiously operate. Montgomery, unchanged since the evening before, said go. Tedder was cautious but did not oppose, but L. Smith, when asked, said it was the best chance they were likely to get. Eisenhower stood up, walked a few paces, and stood at the window looking out at the lawn where a wet grey dawn was beginning to spread over the parkland. He turned back to the room. "Okay," he said, "we'll go." The order went out at once. The recall of the previous night was reversed. The convoys that had turned about were signalled to sail again. The airborne divisions began their final preparations. The blackening of faces, the last inspections of equipment, the reading aloud in some units of Eisenhower's order of the day, the carefully composed message telling them they were about to embark upon the Great Crusade. All through the 5th of June, along a 200-mile stretch of the southern English coast, the ships that had been recalled came out again, formed up again into their assigned columns, and moved south into a channel where the wind was still blowing hard, but where, above the ragged horizon, the cloud was starting to break. By the small hours of the 6th, the leading elements of the fleet were in position off the Normandy coast. Behind them, in a long, staggered column stretching back to the English shore, 5,000 vessels were converging on 5 beaches over a 50-mile front. Above them, in the darkness, the transport aircraft carrying the American 82nd and 101st and the British 6th Airborne Divisions were droning south across the Channel, following coloured lights on the lead planes, threading between the flak batteries of the Cotentin, dropping their sticks of paratroopers over hedgerows and flooded fields and orchards, where, in some cases, The pathfinders were already burning their marker beacons, and in many cases they were not, because the pathfinders had been scattered by anti-aircraft fire and by the wind that Stagg's forecast, honest to the end, had warned would still be there. The airborne landings in the small hours before dawn went in first. They went in scattered, units mixed together, sticks dropped miles from their objectives, whole battalions reassembling by 2s and 3s in the dark, moving on their objectives by improvisation and the drilled memory of the sand table exercises they had rehearsed for months. The 6th Airborne, on the eastern flank, seized the bridges over the Orne and the Caen Canal in a coup de main operation that landed gliders within yards of their targets. The 82nd and 101st dropped over the base of the Cottonton Peninsula, spent the night finding each other in the hedgerows and taking, piece by piece, the causeways behind Utah Beach that the seaborne assault would need in the morning. At first light, the naval bombardment began. Battleships that had been built for another war, the American Texas and Arkansas and Nevada, the British Warspite and Ramillies, opened fire from positions several miles offshore, their 14 and 15-inch guns throwing shells the weight of small cars into the coastal batteries and strong points of the Atlantic Wall. Cruisers and destroyers moved in closer and worked over the beach defences at shorter range. Rocket-firing landing craft, purpose-built for the operation, saturated the shoreline in the last minutes before H-hour, with barrages that turned strips of sand and dune into curtains of fire. At 6:30 in the morning on the American beaches, and a little later on the British and Canadian beaches to the east, the first waves of assault infantry went ashore. Utah Beach, on the far western end of the invasion front, went well. A combination of navigational error and enemy weakness. The leading landing craft came in over a mile south of their intended sector, where the German defences were thinner, allowed the 4th Infantry Division to get ashore with light casualties and push inland to link up with the airborne troops on the causeways. By the end of the day, Utah had cost the Americans fewer than 200 killed and wounded, a figure that would have seemed miraculous to anyone who had studied the pre-invasion casualty estimates. Omaha Beach, some 15 miles to the east, was another matter. There, the 1st and 29th Infantry Divisions came ashore against a stretch of coast whose geography, a curving beach overlooked by bluffs 150 feet high, cut by 4 narrow draws that were the only routes off the sand, had been fortified into a killing ground of interlocking machine gun fire, mortar pits, and concealed artillery. The preparatory bombardment, whether because of low cloud, poor visibility, or the compressed timing of the schedule, had largely overshot the beach defences. The DD amphibious tanks meant to support the first waves foundered in the swell. Most of the 741st Tank Battalion's Shermans, launched too far out, sank in the channel with their crews. The infantry, wading ashore in chest-deep water, in some cases seasick from hours in the landing craft, in some cases weighed down by equipment they could barely stand up in, walked into fire that cut down whole sections at the waterline. For most of the morning, Omaha hung by a thread. On the American side of the fleet in the command ships offshore, staff officers looked at the fragmentary reports coming back from the beach and, in some cases, seriously considered evacuating what was left of the first waves and diverting the follow-on formations to Utah or to the British beaches. It was individual initiative, on the sand and at the base of the bluffs, that held Omaha together. Small groups of infantry and engineers, sometimes led by junior officers, sometimes by sergeants, sometimes by no one in particular, working their way up the draws and over the bluffs and taking the strong points from the flank and the rear. By early afternoon, the beach was still under fire, still congested with wreckage and casualties, but a foothold on the high ground had been secured. By evening, the 2 American divisions had suffered somewhere between 2,000 and 4,000 casualties on that single stretch of beach. The exact figure has never been agreed, and the beachhead they held was, in places, a few hundred yards deep. To the east, on the British and Canadian beaches, the story was somewhere in between. Gold Beach, taken by the British 50th Division, saw hard fighting at the strongpoint at La Hamel, but a general advance inland by evening. Juneau, taken by the Canadian 3rd Division, cost around 1,000 casualties in fighting through the seawall and the villages behind it, and pushed further inland on D-Day itself than any other Allied beach. Sword, on the eastern flank taken by the British 3rd Division, got ashore against relatively light initial resistance and pushed toward Caen, the great objective of the eastern sector, but was checked short of the city by a counterattack from the 21st Panzer Division, the only German armoured formation to reach the beaches on the first day. By nightfall on the 6th of June, roughly 160,000 Allied troops were ashore in Normandy. The beachhead they held was not one continuous line but a scattered set of lodgements, some connected to each other and some not, none of them yet deep enough to be safe from artillery, none of them yet linked to the airborne troops inland in a way that would satisfy the planners' pre-invasion maps. The casualty totals for the day, killed, wounded, missing and captured, across all 5 beaches and the 3 airborne divisions, would settle, in the years of counting afterwards, somewhere between 9 and 10,000 men, with the confirmed dead figured at just over 4,400. It was by any measure a success. It was also by any measure a fragile one. The beachhead was shallow. The Germans had not yet committed their reserves. The panzer divisions in Normandy and behind it, the 21st already engaged, the 12th SS and the Panzer Lehr moving up, the divisions further inland waiting for orders that Hitler had not yet given, were still capable of a coordinated counterstroke that could, in the right circumstances, push the Allies back into the sea. What would decide whether the beachhead held or broke was not the courage of the men on the sand. That had already been demonstrated. What would decide it was what came next, whether the Allies could pour men and vehicles and ammunition and fuel across the beaches faster than the Germans could concentrate their forces to throw them off. It was a logistical race, and it was a race the Germans still had a chance to win, because behind them, in the depots of the Reich, was a supply system that reached back into Germany itself, while behind the Allies was 50 miles of open channel water and no captured port. The pre-invasion planning had understood this from the beginning. The great captured ports of the French coast, Cherbourg on the Cotentin, Le Havre on the Seine estuary, further along Boulogne and Calais and Dunkirk and Antwerp, had been assumed correctly to be either fortified beyond quick capture or upon capture, demolished by the retreating Germans in ways that would take weeks or months to repair. The invasion, in its opening phase, would have no port, and an invasion without a port could not sustain itself. The daily tonnage required to keep a modern army in the field, the fuel for the tanks and trucks, the shells for the artillery, the rations for the men, the medical supplies for the wounded, the replacement parts in vehicles and weapons, was a figure that no beach, worked open by landing craft alone, could supply for very long. By the middle of June, the planners had calculated the invasion force would need something on the order of 12,000 tons of supplies a day. By July, more. By August, more still. That calculation was what the Mulberry Harbours existed to answer. They were not, in the imagination of the men who had designed them, a convenience or an experiment or a hedge. They were the answer to a problem that, without them, had no answer. They were the mechanism by which a shallow, contested foothold on a hostile coast would be turned, over the weeks of June and July, into a base large and secure enough to break out from. They were, in the operational logic of Overlord, the difference between a landing and a campaign. On the evening of the 6th of June, as the beachhead settled into its first uneasy night, the tugs were already hauling the first components of both Mulberries across the channel behind the fleet. The block ships that would form the outer breakwaters were steaming under their own power toward their scuttling positions. The Phoenix caissons, those great grey concrete boxes that would be sunk in ordered lines to make an artificial reef, were being towed at a walking pace through a sea that was still, by the standards of the operation, cooperative. Above them, the ridge of high pressure that Stagg had identified was still holding. The forecast for the following days was uncertain, but not yet alarming. The window that had opened on the 6th was still, just, open. It would not stay open forever. Behind it, in the weather patterns of the North Atlantic, other systems were forming that no forecaster in June of 1944 could yet see. 13 days away, one of them would arrive. To understand what that arriving system would find, and what it would destroy, one has to understand first what was being built to meet it. The Mulberry Harbours were among the most ambitious pieces of military engineering ever conceived, and they were, on the 6th of June, still almost entirely unbuilt. What existed at that hour was a collection of parts, enormous parts scattered across the harbours and estuaries of southern England, gathered over the preceding months by an industrial effort that had strained the British construction industry to its limits and drawn men and materials from projects that had, for the duration, simply been set aside. The whole thing had been imagined and argued over and modelled and prototyped in secrecy through 1943 and into the spring of 1944, and now, in the first hours of the invasion, its component pieces were beginning the slow crossing that would, if the weather held, turn a beach into a port. The idea itself was old, in the way that many good ideas of the war were old. It had been circling in various forms since the disaster at Dieppe in 1942, when a raid on a fortified French port had ended in slaughter and had taught the Allied planners, in the harshest possible way, that a heavily defended deep-water harbour could not be seized by frontal assault. If a port could not be taken, then a port would have to be brought. That was the logic stated at its baldest. A port would have to be manufactured in England, in pieces, floated across the Channel piece by piece, and reassembled on the open coast of Normandy under whatever conditions the sea and the enemy provided. It was the kind of proposal that in peacetime would have been dismissed as fantasy. In the war it had been costed and drawn and built. The pieces were of three main kinds. There were first the Phoenix caissons. These were the great grey rectangular concrete boxes, the largest of them displacing several thousand tons apiece, that would be sunk in ordered lines to form the artificial reef that broke the incoming waves. Each Phoenix was a hollow shell of reinforced concrete, floated across the Channel with just enough freeboard to keep the sea out of its open top, and fitted with seacocks that would, when opened at the correct position, admit the water that would sink it to the seabed. Their scale was industrial. To build the numbers required, dozens of caissons for each of the two harbours had consumed concrete and steel on a scale that had been felt across the British economy, and had required the temporary excavation of basins on the Thames and the south coast simply to have somewhere to lay their keels. Each Mulberry, in the end, would consume something on the order of 140,000 tons of concrete and 100,000 tons of steel. The figures alone give a sense of the ambition. So does the fact that the entire structure had been designed to last only long enough to bridge the gap until a real port could be captured and cleared. A designed lifespan measured in months, achieved at the cost of an industrial effort measured against years of ordinary peacetime output. Outside the Phoenix line, further to seaward, there would be the bombardons. These were the outermost breakwater, a line of enormous floating steel structures, cruciform in cross-section, moored in deep water to break the largest swells before they reached the caissons. They were an experiment. The Phoenixes were massive and solid, and their behaviour once sunk was predictable within the ordinary bounds of civil engineering. The bombardons were another matter. They floated. They rode the sea on chains. Their capacity to hold their station and dissipate energy in the exact conditions off the Normandy coast was a matter, in June of 1944, of calculation and hope rather than of proven experience. They had been tested, inasmuch as anything of that scale can be tested on English coasts in English weather. What they would do in a genuine Channel gale was, and had always been, an open question. Inside the Phoenix line, in the calmer water the breakwaters would create, there would be the pier heads and the roadways. The roadways were the whales, 10 miles of them per harbour, in 80-foot articulated steel spans, designed to flex with the sea and to rise and fall on the tide. They ran from the shore out to the floating pier heads, on which ships would tie up and be unloaded directly, at any state of the tide, without waiting for the water to reach a particular level. The whales rested on floating steel pontoons, the beetles, that held the roadway sections at the working height and allowed them to move with the swell. The whole assembly was in principle elegant. Ships would come into the sheltered water inside the breakwaters. They would moor at the pier heads. Their cargoes, tanks, trucks, palletized supplies, would come off directly onto the whale roadways, drive down the flexible spans to the shore, and be on French soil within minutes of arrival. In principle, again, in principle, in calm water, on a working sea. The whale's capacity to hold together in a genuine storm had not been tested at scale. Nothing about the harbours had been tested at scale, because until they were assembled off Normandy they did not exist at scale. Every calculation was a paper calculation. Every projected wave height and stress figure was a projection. The first true test of the design would be the sea itself. Mulberry A was to be assembled off Omaha Beach in the American sector. Mulberry B was to be assembled off Arromanches in the British sector, several miles to the east. On the map they looked similar enough. Two artificial harbours, sited off open beaches on the same stretch of Norman coast, built to the same designs, protecting roughly the same amount of water. In practice, and in ways that would become tragically important 13 days later, they were not the same at all. The two sites differed in the shape of the seabed offshore, in the presence and position of natural sandbanks that would, or would not take some of the energy out of an incoming swell, and above all in the exact angle at which any given weather system's waves would strike them. A storm blowing from one quarter would hit them differently. The ridge and trough of the Norman coast, the way one headland sheltered another, the way a bank a mile offshore could break the largest waves before they reached the caisson line, all of this was known in general terms to the engineers who had chosen the sites, but only in general terms. The specific behaviour of the two harbours in any specific weather event was, again, something that could only be discovered when it happened. Mulberry Bee at Arromanches benefited from local sandbanks and from an orientation that, as it happened, would prove more forgiving to the storm that was coming. Mulberry A, off Omaha, was in every relevant respect more exposed. The men towing its components across the channel on the 6th and 7th of June could not have known this. Neither could the engineers who would supervise its assembly through the following 2 weeks. The difference between the two sites was latent in the geography, and it would be revealed only when the geography was tested. The tow itself was an operation of extraordinary difficulty. The Phoenixes were not in any nautical sense ships. They were concrete boxes that had been made just barely capable of floating long enough to be moved. Their draft was deep. Their freeboard was minimal. In any significant sea they were nearly submerged, and the tugs pulling them had to hold a steady course at 3 or 4 knots across a body of water that was, at the best of times, one of the most difficult tidal seas in Europe. To move a Phoenix from a scuttling basin on the Thames to a position off Normandy took days. To do it in a working invasion, with warships and landing craft crossing the same lanes, with mines swept and the swept channels marked, with air cover overhead, and E-boats presumed still active in the coastal waters, this was an operation whose difficulty is difficult now to communicate. The one-day postponement of the invasion on the 5th of June had already, at that early stage, forced a mid-channel halt on some of the tug convoys. Even before the landings, the Mulberry programme had shown how tightly its timing was wound around the weather. A day's delay was a day's exposure. Every hour of every tow, the caissons and pontoons were at the mercy of whatever the sky decided to do. By the evening of the 6th of June, the first components were arriving off the beaches. Block ships, old merchantmen and elderly warships, some of them survivors of a previous war drawn from reserve fleets in Britain and America, were being manoeuvred into position and scuttled in ordered rows to form the first, most makeshift element of the breakwater. The gooseberries, as they were called, lines of sunken hulls that would provide immediate shelter for landing craft even before the Phoenixes arrived. The scuttling itself was a controlled process. Charges were set, seacocks were opened, the old hulls settled onto the seabed in the depth of water for which they had been chosen, their upper work standing above the surface as a first ragged breakwater. It was the sort of expedient the whole Mulberry programme was built on. Use everything, waste nothing, keep the material coming. Behind the block ships, over the following days the Phoenixes began to arrive, and the same procedure, with far greater precision, was carried out on each of them. A Phoenix was towed into position, aligned to its neighbours, and sunk on a rising tide so that its base settled evenly onto the prepared bottom. Once sunk, it was ballasted further, tied to its neighbours, and became part of the wall. A Phoenix line, complete, looked from the shore like a low grey sea wall standing improbably out in the open ocean, a horizon line of concrete where 2 weeks earlier there had been nothing but water. Behind it, in the sheltered lee, the pierheads were being anchored and the whale roadways floated out from the shore and connected span by span. The beetle pontoons rose and fell on the tide. The whole structure grew day by day, an industrial city assembling itself on the open sea. None of it on the 6th of June was finished. None of it on the 10th was finished. On the 19th, the day the storm arrived, most of the essential structure of Mulberry A was in place, but much of it was still being tuned, tested, reinforced, tied in. The harbour was operational, it was not complete. Supplies had begun coming through the pierheads. The daily tonnage was climbing toward the planned figure. But the harbour was, in every engineering sense, still an unfinished building. The men working on it did so under the reassuring conditions of a Channel summer, in one of the calmer years of the century's weather record. They knew a storm would come eventually. They did not know when. The storm, when it came from the northeast. That direction mattered. The Mulberry harbours had been designed, insofar as they had been designed for any particular weather, for the prevailing westerlies of the Channel. A gale out of the west was the expected enemy. A gale out of the northeast was a different animal, striking the harbours from an angle their breakwaters were less shaped to receive, and driving waves against the outer face of the Phoenix line with a fetch that ran unbroken across the open sea from the Dutch coast. On the morning of the 19th of June, the wind rose. By midday it was blowing at gale force. By evening it had settled into what would prove to be a sustained 3-day event, with winds gusting to something on the order of 60 miles per hour, and seas building in the shallow waters off the Norman coast to heights that had not been seen in the Channel in living memory. The exact framing of the historical comparison varies across sources, the worst in 20 years, in 40, in 80. But the agreement on severity is total. This was, by any measure, a June storm of a kind the meteorological record simply did not contain. It should not have been happening in that month at all. That it was happening, on that particular date, off that particular coast, was one of those coincidences of history that afterwards seem almost too neat to be believed. The seas built through the 19th and into the 20th, the wave heights, in the reanalysis studies that have been carried out since, with modern computational tools, are estimated at something in the range of 13 to 19 feet, Force 7 conditions in the classification used at the time, with individual waves running considerably higher in the shallow water inshore. Wind and sea combined to drive an enormous body of water repeatedly against the outer face of Mulberry A. The bombardons, the outermost floating breakwaters, went first. Some of them broke their moorings, others broke apart on their moorings. Either way, the outer line of defence dissolved within the first day of the storm, and the full force of the sea reached the Phoenix caissons with an energy the designers had not, in the end, provisioned for. The caissons, sunk in their ordered rows, began to move. Some of them cracked under repeated impact. Others were lifted incredibly by the surge and resettled at odd angles. The line went ragged. Water began pouring through the gaps between damaged caissons, and once water was inside the harbour, the sheltered lee was gone, and everything inside, the pierheads, the whale roadways, the beetle pontoons, the ships that had been unloading and had had no time to get clear, was in the storm too. The beetles were the killers. The floating pontoons that supported the whale roadways, torn from their positions by the surge, began to hammer against the caissons and the pierheads and against one another. The harbour's own components became projectiles inside the harbour. The whale roadways, articulated to flex with an ordinary sea, could not absorb the loads that a genuine storm sea was putting through them, and the spans broke apart section by section and were driven ashore in tangled heaps of steel. Small craft caught inside the harbour were smashed against the caissons or driven up onto the beach. Larger vessels tried to ride it out on their anchors, and in many cases dragged those anchors across the seabed and ended up aground themselves. The number of vessels driven ashore or lost during the 3 days of the storm reached, in the final accounting, something on the order of 800, a figure that includes everything from major landing craft to small workboats. But that gives, even at that range, some sense of the scale of the destruction. This was not, in any conventional sense, damage. This was the systematic disassembly of a harbour by a sea that had turned every piece of it into a weapon aimed at every other piece. Off Arromanches, several miles to the east, Mulberry B was suffering too. Its breakwaters were battered. Its own bombardons, where they existed, were broken up in the same way. Waves reached its Phoenix line and did their work there as well. But the geography did what geography does. The sandbanks offshore of Arromanches broke some of the largest incoming waves before they reached the caisson line. The angle at which the northeasterly seas struck the harbour was, by the accident of coastline, less directly destructive than the angle at which they struck Mulberry A. The damage at Arromanches was severe. It was not total. When the wind dropped on the 22nd and the sea began to fall, Mulberry B was still there. Battered, gapped, in need of extensive repair, but structurally intact enough to save. Mulberry A, off Omaha, was not. Its caissons were cracked and displaced beyond the point where the engineers on site judged repair to be practical in the time available. The decision was taken to write it off. The Great Grey Line off Omaha would not be rebuilt. What was done instead was to strip it for parts. Salvage crews worked through the following weeks, pulling every serviceable Phoenix, every intact stretch of whale roadway, every beetle that could still float, out of the wreckage of Mulberry A and towing them east to Arromanches, where they were used to repair and reinforce Mulberry B. The British harbour, patched with American parts, went back into service, and over the following 8 months, until the port of Antwerp was captured and cleared in the autumn and the artificial harbour became unnecessary. Mulberry B, Port Winston, the men called it, handled the tonnages the planners had asked of it. 7, 8, at times 9,000 tons of supplies a day poured across its roadways and onto the roads inland. The figure quoted in the official accounts is on the order of 6,765 tons a day, averaged across the whole period from the 20th of June to the 1st of September, which is a great deal of tonnage to move across an artificial roadway anchored in an open sea. That the harbour did this work at all, after what the storm had done to it, is one of the quieter engineering achievements of the war. That, then, is what the storm did to a harbour that had had 2 weeks to establish itself, that had had time to be tested and shaken down and tuned in the ordinary way that such a structure needs. That is what the storm did to a fleet that had already offloaded most of its assault troops, that had already worked its most vulnerable landing craft up onto the beach and unloaded and dispersed inland. That is what the storm did to a beachhead that had, by the 19th of June, already absorbed 150,000 tons of supplies through its 2 mulberries and its open beaches, that had already built up something on the order of 500,000 men ashore, that had already established fuel dumps and ammunition dumps and field hospitals and forward airfields on the French soil behind the sand. That is what the storm did to a beachhead that was, by any operational measure, in place. Everything to this point in this narrative is documented. Every ship, every caisson, every wind speed, every casualty figure is drawn from the accounts of men who were there, and from the reanalyses that have been carried out since. Group Captain Stagg's forecast, Eisenhower's decision at Southwick House in the early hours of the 5th of June, the 24-hour postponement, the narrow clearing window, the crossing on the night of the 5th into the 6th, the landings on the 6 beaches at first light, the 14 days of consolidation, the storm that arrived on the 19th and destroyed Mulberry A. All of this is history. None of it is speculation. What follows now, from this point in the narrative onward, is. The question the documentary now asks is a single question, and it is a question that turns on a single hinge. What if Stagg had not seen the clearing window on the morning of the 5th? What if the ridge of high pressure had been narrower, or shorter-lived, or later in arriving, and what Stagg had reported to Eisenhower had been not a marginal opportunity, but the continuation of the gale? What if Eisenhower, faced with a forecast that offered no window, or with a window so narrow that he could not in conscience commit 5,000 ships to it, had chosen to wait? The postponement in that case would not have been for 24 hours. It would have been for 2 weeks. The tides and the moonlight that Overlord required, a rising tide at first light for the landing craft to clear the beach obstacles, moonlight for the airborne drops in the hours before dawn, did not come together again in a workable combination until the 19th of June. That is not a supposition. That is the astronomy. The next window the planners would have targeted, had the June the 6th window closed, was the window that opened on the 19th, and on the 19th, at first light, in the exact hours in which the invasion fleet would have been approaching the Norman coast, with the leading landing craft being lowered into the water from the transports, with the airborne divisions already scattered across the Cotentin, with the tugs and the phoenixes and the block ships still strung out across the middle of the channel, the storm arrived. Not later in the day, not the following day, on the 19th. The 2 dates, the date of the invasion in the alternative history and the date of the storm in the actual history, are the same date. The one condition on which the whole speculation rests is not a supposition invented for narrative convenience. It is a matter of the calendar. The astronomy that set the window and the meteorology that delivered the storm are 2 independent systems, and in June of 1944 they happened, by no design of anyone's, to coincide. That coincidence is the whole engine of the speculation that follows. It is what allows the question to be asked with something more than idle interest. It is what turns the counterfactual from an exercise in imagination into an exercise in extrapolation from a documented event. The storm that would have hit the fleet on the 19th is not a storm anyone has to invent. It is the storm that hit the beaches on the 19th. Its wind speeds, its wave heights, its duration, its direction, all are known. What is not known, and what the following portion of this narrative will attempt to reason through, is what that documented storm would have done to a fleet caught not 14 days into a consolidated beachhead, but at the single most vulnerable hour of an amphibious operation, the hour of the landing itself, the men crossing in landing craft, the phoenixes still in tow. The pier heads not yet anchored, the block ships not yet scuttled, the whale roadways still on their journeys from English ports. Every element of the operation whose fragility had been shown, in the real timeline, by what happened at Omaha, would have been in the water at the moment the storm arrived. The line between the history that happened and the history that did not is, at that hinge, a single forecast delivered in the small hours of the morning of the 5th of June in a country house in Hampshire by a Scottish meteorologist to an American general. Everything that follows from this point on follows from what would have happened if that forecast had read differently. The ships were already at sea, the men were already aboard. The decision, in the alternative history, is simply to hold, to keep the fleet in its assembly areas, to accept the 2-week wait, to try again on the 19th in the next window the moon and the tide would permit. And on the 19th, at first light, in that alternative history the northeasterly wind would begin to rise. The first vessels to feel it would be the smallest. The Higgins boats, the LCVPs that carried 36 men each in their open steel wells, drew only 3 feet of water when loaded. They were designed for beaches, not for open crossings. In the actual invasion, they had been lowered from their motherships only in the final miles, ferrying their human cargo from the transports to the sand. But even in that brief exposure to the channel on the 6th of June, in conditions that Stagg had judged acceptable, the small craft had shipped water over their gunwales. Men had arrived on the beaches soaked and shivering, some already vomiting from the motion, their rifles slick with spray. That was in acceptable conditions. That was in the window Stagg had identified as workable. In the conditions of the 19th, those same craft would not have shipped water. They would have filled. A wave height of 3 to 4 meters, 10 to 13 feet, arriving from the northeast in the exposed waters of the mid-channel, would have swamped an LCVP in minutes. The craft had no pumps adequate to the volume. They had no covers. They were steel boxes open to the sky, and in a following sea of that magnitude, the following sea would have come aboard. The men inside, weighted with 60 to 80 pounds of equipment, would have had nowhere to go. The craft would have lost way, turned beam onto the waves and rolled. This is not speculation about what might have happened. This is naval architecture. A shallow draft vessel with a flat bottom and no keel, caught beam on in a breaking sea, capsizes. The physics do not vary with the courage of the men aboard. The larger landing craft, as the LCTs that carried tanks, the LCIs that carried infantry companies, would have lasted longer. They had deeper drafts, enclosed spaces, some capacity to fight the sea. But they too had been designed for the final approach, not for extended exposure to open water in gale conditions. The LCT landing craft tank was essentially a floating box with engines. It had no bow in the nautical sense, only a ramp that dropped to discharge its cargo. That ramp, in heavy seas, became a liability. Water forced its way through the seams. The flat bottom pounded against the wave faces with a violence that loosened rivets and opened seams. In the actual June 19th storm, LCTs that had already discharged their cargoes and were riding at anchor in the partial shelter of the Gooseberry breakwaters, the lines of scuttled ships that provided some protection, were torn from their moorings and driven onto the beach. Some were wrecked beyond salvage, and those were empty vessels in partially sheltered water. A loaded LCT, carrying a Sherman tank or two, crossing the open channel in the teeth of a northeast gale, would have faced a different calculus. The tank, lashed down in the well deck, would have shifted with each roll. The lashings would have worked loose or snapped. 30 tons of steel, once free, becomes a battering ram inside its own vessel. The crew, fighting to maintain headway into the seas, would have watched the cargo they were meant to deliver destroy the ship from within, and if the tank stayed secured, the weight of it, low in the hull as it was meant to be, would have kept the vessel upright but would not have kept the seas from boarding. Water in the well deck adds weight. Weight reduces freeboard. Reduced freeboard admits more water. The sequence, once begun, does not reverse itself. Across the width of the invasion fleet, in the alternative history of a June 19th crossing, this sequence would have been repeating itself in hundreds of vessels simultaneously. The scale of the operation that had been so carefully assembled, the 5,000 ships, the 11,000 aircraft, the 156,000 men scheduled for the first wave, would have become the scale of the catastrophe. There is no rescue operation adequate to a fleet in distress across a 60-mile front in a gale. The destroyers and corvettes that might have attempted to take men off sinking craft would themselves have been fighting for their own survival. The transports, The big ships that carried the troops to the lowering points would have been rolling through arcs of 30 degrees or more, their cranes useless, their davits unmanned, their own crews hanging on. In such conditions, the small craft are on their own, and in such conditions, the small craft die. The Mulberry components, still in transit, would have faced their own destruction. The Phoenix caissons, the concrete boxes that formed the breakwater, were being towed across the channel at 4 knots by tugs, straining against their own limitations. A Phoenix displaced 6,000 tons. It had no engines, no steering, no crew. It was a dead weight at the end of a cable, and in a beam sea it behaved like a dead weight. The towing cables, under the strain of a vessel that wanted to go one way while the sea pushed it another, would have parted. Once a Phoenix broke free, it became a hazard to navigation. 6,000 tons of concrete drifting across the shipping lanes, invisible in the spray and the murk, waiting to be struck by a vessel that could not see it until too late. In the actual storm, Phoenixes that had already been sunk in position, that were already resting on the bottom with their tops above the waterline, were shifted and broken by the wave action. Those still in transit would not have survived the crossing. The bombardons, the floating breakwaters that were meant to provide the outer ring of protection, would have been torn apart in the open water before they ever reached their stations. In the actual event, after 13 days of relative calm, the bombardons failed within hours of the storm's arrival. Their cruciform steel frames, designed to absorb wave energy, instead transmitted it. The joints worked loose, the sections separated. By the end of the first day of the actual storm, the bombardon line was a scattered wreck. In the alternative history, the bombardons would never have been deployed at all. They would have been destroyed in transit, their wreckage adding to the debris field through which the surviving vessels would have had to navigate. The arithmetic of the alternative is not difficult. The actual storm, striking a beachhead that had been receiving supplies for 13 days, destroyed 800 vessels at Omaha alone. Those were vessels at anchor, in partially sheltered water, behind breakwaters that were at least partially functional. A fleet in transit in open water with no shelter of any kind would have lost more. How many more is not a question that can be answered with precision, but the direction of the answer is not in doubt. The losses would have been measured not in hundreds, but in thousands of craft. The losses in men would have been measured in tens of thousands, and those losses would have occurred before a single soldier set foot on a beach. This is the first layer of the catastrophe that the June 19th alternative would have produced. It is the layer that concerns the crossing itself, the hours between the English coast and the Norman coast, the hours in which the fleet would have been most exposed and most helpless. But the crossing, even in a successful invasion, was only the beginning. The purpose of the crossing was to deliver men to beaches, and the beaches in the conditions of June 19th would not have received them. The gradient of Omaha Beach drops steeply from the high water mark to the low tide line. At low tide, the sand extends 400 yards from the bluffs to the water's edge. At high tide, the water reaches nearly to the base of the shingle bank. The invasion was timed for a rising tide, low enough at H hour that the beach obstacles would be exposed for the demolition teams, high enough by the time the main waves arrived that the landing craft could get close to the dry sand before dropping their ramps. This timing was calculated to the minute. It assumed conditions in which landing craft could control their approach. In a 3 to 4 meter sea, with waves breaking across the outer bar and reforming to break again on the inner bar, no landing craft controls its approach. The surf zone at Omaha, even in moderate conditions, was notorious. The beach faces northeast, directly into the prevailing wind of the June 19th storm. The waves would have been building across the full fetch of the channel, arriving at the beach with their full energy undiminished. A breaking wave of 10 feet carries a force of approximately 1 ton per square foot of surface area. A landing craft caught beam on in such a wave does not right itself, it rolls. The men inside, thrown against the steel sides, weighted with their equipment, tangled with their fellows, have seconds to escape before the next wave arrives. In water cold enough to incapacitate a swimmer in minutes, wearing equipment heavy enough to drag them under, those seconds are not enough. The ramps of the landing craft in such conditions become death traps. The craft grounds on a bar 50 yards from the beach. The coxswain, following his training, drops the ramp. The men surge forward and step into water over their heads, into a current that pulls them sideways, into a wave that tumbles them and holds them under. This is not speculation. This is what happened on the actual 6th of June, in conditions far milder than those of the 19th. At Omaha, on the actual D-Day, men drowned in the surf. They drowned weighted with their equipment. They drowned within sight of the sand, and that was in a sea state that Stagg judged acceptable. In the sea state of the 19th, the drownings would not have been measured in dozens, they would have been measured in thousands. The assault waves, the men who were meant to clear the obstacles and suppress the defenders and open the beach for the follow-on forces, would have died in the water before they reached the fight. The beach obstacles, the steel hedgehogs, the wooden ramps, the Belgian gates, would have remained in place because the demolition teams would not have reached them. The defenders in the bluffs, looking down at a chaos of overturned craft and drowning men, would have had no targets to engage. The battle would have been over before it began, decided not by German firepower but by the sea itself. And even if, by some miracle of seamanship and fortune, some fraction of the assault force had reached the sand, even if a few hundred men, or a few thousand, had fought their way through the surf and crawled up the shingle and taken cover beneath the bluffs, they would have been stranded. The landing craft that delivered them would have been wrecked in the surf or driven back out to sea. The follow-on waves would not have arrived. The tanks that were meant to provide fire support would have drowned in the channel or sunk in the surf. The artillery would not have come ashore. The ammunition would not have come ashore. The food and the water and the medical supplies would not have come ashore. A few thousand men, lightly armed, without support, without resupply, without evacuation, would have clung to a strip of sand beneath bluffs held by an enemy who had only to wait. The Mulberry harbours, in this alternative, would not have existed. The components would have been scattered across the channel floor or driven onto the beaches as wreckage. The carefully planned sequence of construction, the phoenixes sunk in their precise positions, the pier heads anchored, the whale roadways connected, would have been impossible. There would have been no sheltered water for unloading. There would have been no floating piers for the coasters and the Liberty ships. There would have been only the open beach, and the open beach, in the aftermath of a 3-day storm, would have been impassable. The actual destruction of Mulberry A in the real timeline delayed 140,000 tons of supplies. That delay occurred in a context where the beachhead had already been receiving supplies for 13 days. The troops ashore had ammunition, they had food, they had fuel. The delay was painful but survivable. In the alternative timeline, there would have been no 13 days of prior supply. There would have been no stockpiles on the beach. The troops who survived the landing, if any survived the landing, would have been cut off from the moment they arrived. The supply line that was meant to sustain them would never have formed. This is the structural argument against a June 19th invasion, and it does not depend on any speculation about German responses or Allied morale or the political consequences in London and Washington. It depends only on what the documented storm did to things that were already in place, and on the reasonable inference that things still in transit or still being assembled would have fared worse. The Phoenix caissons that broke apart after being sunk in position would have broken apart sooner if caught in the open channel. The bombardons that failed within hours of the storm's arrival would have failed immediately if the storm had arrived while they were still being towed. The landing craft that were wrecked at anchor would have been wrecked at sea. The men who drowned in the surf on the 6th of June, in acceptable conditions, would have drowned in greater numbers in unacceptable conditions. The scale of the catastrophe is not calculable with precision, but its shape is clear. An invasion fleet of 5,000 vessels caught in the open channel by a storm of documented severity would have suffered losses sufficient to abort the operation. An assault force attempting to land on beaches swept by 10-foot surf would have suffered casualties sufficient to prevent the establishment of a viable beachhead. A logistics operation dependent on artificial harbours that could not be assembled would have failed to deliver the supplies necessary to sustain any troops who did get ashore. The three elements of the invasion, the crossing, the landing and the sustainment, would each have failed independently, and the failure of any one would have been sufficient to doom the whole. This is not a story about what might have gone wrong, it is a story about what would have gone wrong, given what we know about what actually happened when the same storm struck the same beaches 2 weeks later. The difference between the actual history and the alternative history is not a difference in the storm. The storm is the same storm. The difference is in what the storm encountered. In the actual history, it encountered a beachhead. In the alternative history, it would have encountered a fleet. The distinction matters because it determines the nature of the catastrophe. A beachhead absorbs a storm. It loses supplies, it loses time, it loses momentum, but it survives, because the men are already ashore, because some shelter exists, because the logistical network, though damaged, can be repaired. A fleet at sea does not absorb a storm. It is destroyed by it. The men are not ashore. The shelter does not exist. The logistical network has not yet been built. Everything that would later provide resilience is still in transit, still vulnerable, still exposed. The gooseberries, the lines of scuttled blockships that provided the innermost ring of shelter at each beach, would not have been in place. The blockships were scheduled to be sunk in the first days after the landing, once the assault waves had secured the beach exits. In the alternative timeline, the assault waves would not have secured the beach exits. The blockships would have been caught at sea, or they would have been held in English ports awaiting a landing that never succeeded. Either way, they would not have been where they were needed. The partial shelter that allowed Mulberry B to survive the actual storm would not have existed. The salvage operation that saved Mulberry B, the transfer of components from the wrecked Mulberry A to reinforce the damaged Mulberry B, would have been impossible. There would have been no Mulberry A to salvage, because Mulberry A would never have been assembled. There would have been no Mulberry B to reinforce, because Mulberry B would have suffered the same fate. The engineering triumph that allowed the British harbour to continue operating for 8 months after the storm, delivering 2.5 million men and 4 million tons of supplies, would not have occurred. The harbour that sustained the campaign would not have existed. The implications cascade outward from the beach. Without a functioning harbour, the beachhead cannot be supplied. Without supplies, the beachhead cannot expand. Without expansion, the beachhead cannot survive a determined counterattack. The troops ashore, if any troops are ashore, are trapped in a perimeter that shrinks daily as ammunition runs low and casualties mount. The Germans, who in the actual timeline were caught off balance and slow to respond, would have had time to concentrate their forces. The counterattack that never came in the actual history, because the beachhead expanded too quickly, because the supplies kept flowing, because the initiative remained with the Allies, would have come in the alternative history, and it would have found defenders who had nothing left to fight with. This is the logic of the alternative, and it is a logic built not on imagination but on extrapolation. Every element of the catastrophe is derived from something that actually happened. The storm actually occurred. The Mulberry actually failed. The landing craft actually struggled in far milder conditions. The supply delays actually crippled operations even with a functioning beachhead. The alternative simply asks what happens when all of these documented difficulties occur simultaneously, at the moment of maximum vulnerability, with no margin for recovery. The answer is that the invasion fails, not because the Germans were too strong, not because the Allies made mistakes, not because the plan was flawed. The invasion fails because the weather, which no one controls, arrives at the worst possible moment, and because the worst possible moment is the moment that the calendar and the astronomy had designated as the only available alternative. And yet the weather is only half the equation. Turn the map around. Look across the channel from the other shore, from the bluffs and hedgerows of Normandy, and consider what those same 13 days would have meant to the man who had spent months preparing to meet the invasion at the water's edge. Field Marshal Erwin Rommel was 52 years old in the spring of 1944, and he had come to command Army Group B, responsible for the coastal defence of France from the Scheldt estuary to the Loire, with a very specific conviction shaped in a very specific school. He had learned in the deserts of North Africa what Allied air power did to armoured reserves attempting to move by daylight. He had watched columns of tanks and half-tracks strafed and bombed on open roads, watched fuel trucks burn, watched the logic of manoeuvre warfare collapse under the weight of aircraft the Luftwaffe could no longer challenge. He arrived in France with a single hard-won lesson. Whatever reserves Germany intended to commit against a Western landing had to be committed at the shoreline in the first hours, before Allied air supremacy could paralyse their movement. The invasion, he told his aide Captain Helmuth Lang in April of that year, would be decided in the first 24 hours. He called that day the longest day. He meant it not as rhetoric, but as operational doctrine. The beach was where the battle would be won or lost. Not everyone agreed. Field Marshal Gerd von Rundstedt, 68 years old, Commander-in-Chief West, held to an older school of manoeuvre. He believed the Allies should be allowed to land, drawn inland, and then destroyed by concentrated armoured counterattack once their axis of advance had revealed itself. The panzer divisions, in his view, belonged well behind the coast, positioned to strike wherever the main effort emerged. The dispute between these two men, and the compromise that Hitler imposed upon it, defined the German posture on the morning of June 6th. Panzer Group West was held as a strategic reserve under the personal control of the Führer himself. Rommel could not release it. Von Rundstedt could not release it. When the landings came, precious hours were lost in the effort to secure permission to move divisions that neither field marshal fully commanded. That was the situation on June 6th. Now imagine the situation on June 19th. The specifics are impossible to know. This is where the thought experiment must speak with a quieter voice, because the archives can tell us what Rommel was doing, but not what he would have done. What the archives do tell us is that Rommel was not standing still. Through the spring of 1944, he had been reinforcing the Atlantic Wall at a pace that reflected the urgency of his conviction. Between January and June, the Normandy sector alone had received roughly 2,000 additional reinforced concrete structures and something on the order of 200,000 new beach obstacles. Along the wider French coast, by the eve of the invasion, some 500,000 steel and concrete obstacles crowded the tidal flats. Czech hedgehogs of welded rail, Belgian gates hinged and mined, tetrahedra squatting in the sand, wooden ramps designed to flip landing craft as they came in on the tide. Behind the beaches, in the fields where the airborne divisions were expected to land, tens of thousands of stakes had been driven into the ground and wired with charges. The soldiers who installed them called the work by Rommel's name his asparagus, skeletal, waist-high, spaced to catch a glider's wing. The minefields tell the same story of urgent, incomplete work. By June, some 4 to 5 million mines had been laid along the Atlantic Wall. Rommel wanted 100 million. He did not have them. German production could deliver perhaps 100,000 mines a month. When factory-made mines ran short, his engineers improvised, packing explosive into captured French artillery shells and burying them in the sand. The goal was a defensive belt 6 miles deep along the coast, what Rommel privately called the Death Barrier. On June 6th, that belt existed only in patches. It was thickest where he had expected the blow to fall and thinner elsewhere. Even at its densest, the assault waves punched through it in a matter of hours. Now give Rommel 2 more weeks. The precise arithmetic is unknowable, and honesty requires us to say so. But the direction of the change is not unknowable. 2 more weeks of mine-laying at the observed pace of German engineer battalions would have added mines to sectors that on June 6th had been only lightly seeded. 2 more weeks of obstacle installation would have thickened the tidal belts, extended the belts of asparagus in the drop zones, closed gaps that reconnaissance photographs had identified as weak points. The strong points along the bluffs, the concrete casemates whose fields of fire dominated Omaha and dominated Utah and dominated the beaches between, would have received additional ammunition, additional overhead cover, additional wire. None of this is speculation about German capacity. It is extrapolation from what German engineers were documented as doing in the days and weeks immediately before June 6th, and what they would presumably have continued doing had the invasion not arrived. There is also the matter of the command dispute, and here the extrapolation becomes more speculative but no less serious. The argument between Rommel and von Rundstedt over the placement of the Panzer reserves had not been resolved on June 6th. It had been suspended in a sense by an unhappy compromise that satisfied no one. 2 additional weeks of pressure from Rommel, who was in June 1944, growing increasingly certain that the invasion was imminent and increasingly frustrated by the constraints on his authority, might have produced a shift. It might not. Hitler was capable of holding a position against any amount of pressure, but the possibility exists that some fraction of the armoured reserve might have been released to positions closer to the coast, whether through Rommel's persuasion, through a fresh assessment by the German staff, or simply through the accumulating weight of intelligence indicators pointing toward Normandy. If even one additional panzer division had been positioned within striking distance of the beaches, the counter-attack calculus of the first 48 hours changes materially. And the counter-attack calculus, in an alternative timeline where the beachhead has been shattered by the storm and the supply line has never formed, is not a calculation the Allies can afford to lose. There is also the question of what the Germans might have learned. The Allied deception plan, Operation Fortitude, was a masterpiece of misdirection that had convinced the German High Command that the real invasion would come at the Pas de Calais, opposite Dover, and that any landing in Normandy would be a diversion. On June 6th, that deception held. It held for weeks afterward, in fact, because the German staff continued to expect a second, larger landing further north, and continued to hold the 15th Army in place waiting for it. But deception operations are not immortal. They depend on the enemy not receiving contradictory information. Every additional day between the initiation of the deception and the actual landing was a day in which agents could be turned, patterns could be detected, wireless traffic could be reanalyzed. 2 more weeks might have made no difference to Fortitude's success, or it might have made every difference. The historical record does not tell us, because in the historical record the invasion arrived before the question was tested. What the historical record does tell us is that Rommel himself was not at his headquarters on the morning of June 6th. He had returned to Germany to visit his wife on her birthday, a trip made possible by his own reading of the weather forecast, the same weather that convinced the Allies to postpone, convinced the Germans that the coming days were not a threat. Rommel was away because he trusted the sea to hold the Allies back. In the alternative timeline, he is not away on June 19th. He is at his headquarters. He has been at his headquarters for 2 additional weeks, tightening every screw he can reach, arguing every point he can argue, driving his engineers, his gunners, his infantry battalions to prepare for what he believes with growing certainty is imminent. He's not caught off balance. He's not on the road from Herlingen when the first reports come in. He's at La Roche-Guyon, at his map table, ready to give the orders he had rehearsed 1,000 times in his mind. None of this guarantees a different outcome. The Germans had structural weaknesses that no amount of preparation could resolve. The divided command, the fuel shortages, the impossibility of moving armour by day beneath skies owned by Allied fighters. But those structural weaknesses were mitigated on June 19th in the alternative timeline by a factor that would have neutralised the greatest Allied advantage. In a storm of the severity that actually struck the Channel that day, the fighter bombers do not fly. The rocket-firing Typhoons of the 2nd Tactical Air Force do not fly. The P-47s and the Mustangs do not fly. The German columns that in the actual campaign were savaged on every road during daylight hours can, for as long as the storm lasts, move freely. 3 days is not long in the abstract. 3 days, given to a field marshal who has been begging for the freedom to move armour to the coast, is time enough to redistribute a battle. Layer that against a fleet in ruin. Layer it against beaches where the landing craft never reached the shore, or reached it in fragments, without armour, without artillery, without the supplies to sustain even the men who survived the surf. Layer it against a command in London that has just watched, in the space of 72 hours, the largest amphibious operation in history come apart in front of it. This is the shape of the alternative. It is not a shape that resolves cleanly, but it is a shape whose outlines can be traced with reasonable confidence from documented ground. And the alternative does not end at the Norman shore. Turn now to the wider map. Consider what a failed or aborted June invasion attempt would have meant to the entire architecture of the Allied war in 1944, because the invasion was not a single operation planned in isolation. It was a hinge. It was the western half of a coordinated squeeze upon Germany that had been agreed upon at Tehran in December of 1943, when Roosevelt and Churchill and Stalin had sat around a table in the Persian capital and worked out, in the deliberately vague language of coalition warfare, the timing of what would come next. Stalin had promised a great summer offensive in the east. The Western Allies had promised the Second Front in France. Both promises were to be kept in the spring or early summer of 1944. Both promises depended on the other. Operation Bagration began on June 22, 1944. It began 3 days after the storm hit the Channel, 16 days after the actual D-Day landings. It was the largest single ground operation the Soviet Union would launch in the entire war, and it was designed to fall upon Army Group Center at the moment when German strategic attention was fixed westward, wrestling with the crisis in Normandy. In the actual timeline that synchronization worked, Hitler could not reinforce the east because he was bleeding divisions west. He could not reinforce the west because Bagration was tearing apart his line in Belorussia. The two fronts consumed each other in a mutual exhaustion that the German war economy could not sustain, and within weeks the Wehrmacht as a coherent strategic instrument had begun to break. Remove D-Day from that equation, or worse, replace it with a visible public catastrophic failure, and the coordination dissolves. Bagration still launches on June 22nd because Stavka's plans are its own and its timetable is set, but it launches against a Germany that has just been given a demonstration that the Western Allies cannot cross the Channel. Divisions that in the actual history were rushed from the east to reinforce Normandy remain in the east. Divisions that in the actual history were held ready in France for the anticipated second landing at the Pas de Calais are freed, over time, to move to other fronts. The Wehrmacht in the summer of 1944 is a broken instrument in either timeline, because Bagration alone is enough to shatter Army Group Centre. But the pace of the collapse changes, the strategic pressure on Berlin changes, the calendar of what remains of the war changes, and the political calendar in the West changes with it. Roosevelt was, in June of 1944, 5 months from a presidential election, a failed invasion, thousands of American boys drowned in the Channel, the beaches littered with wreckage, the great enterprise reduced to a photograph of catastrophe, would have arrived in the American newspapers as a wound that no amount of subsequent explanation could close. Churchill's political position was less exposed to immediate electoral judgment, but his relationship with his own military planners had for years been shadowed by his memory of Gallipoli and by his colleagues' fear that he would repeat it. A failure in Normandy would have vindicated every skeptic who had counselled caution about a direct assault upon Fortress Europe. The pressure to shift the emphasis of the Western War back toward the Mediterranean, toward the Italian campaign, toward peripheral operations rather than a second attempt at a channel crossing, would have been immense. Whether that pressure would have prevailed is another question the historical record cannot answer. But the pressure would have been there, and it would have consumed months. Then there is the human calendar of occupied Europe. Every resistance movement in France, in Belgium, in the Netherlands, in Denmark and Norway had spent the spring of 1944 preparing for the moment when the great signal would come from London. The coded messages on the BBC, the sabotage instructions, the rail-cutting operations that were meant to be timed to the invasion. Many of those operations were executed in the actual first week of June, and the Germans responded to them with the reprisals that were their standard practice. The destruction of villages, the execution of hostages, the collective punishments that stained the summer of 1944 with names like Oradour-sur-Glane. Those reprisals happened even against the backdrop of a successful invasion, in a timeline where the invasion fails and where the resistance networks have been activated, and where the Germans have not been pushed onto the defensive but have instead been visibly strengthened by a great victory. The reprisals do not stop. They accelerate. Networks that in the actual history survived because the Allied advance overran the German security services would, in the alternative, be systematically dismantled. Agents would be captured. Radios would be silenced. The infrastructure of internal opposition that the SOE and the OSS had spent years building would be lost in a summer of executions. And behind all of this stands the question that no one asked aloud in June of 1944, but that hovered over every strategic calculation, the question that historians have argued about ever since. Could the war still have ended in 1945? Could it have ended at all in the near term, without a Western Allied lodgment on the continent? Some historians argue that Soviet advances alone would have brought Germany to its knees regardless of what happened in the West, that the sheer scale of Bagration and its successors made the outcome inevitable, and merely shifted the timetable and the map of the eventual peace. Others argue that a failed Western invasion would have prolonged the war by a year or more, delayed the discovery of the death camps, shifted the post-war borders of Europe far to the west of where they eventually settled, placed the atomic weapons that arrived in the summer of 1945 into a different strategic conversation entirely. These are not questions this thought experiment can resolve. They are questions the thought experiment can only pose, and pose seriously, because the pivot point that opens them is not fantasy, but a single meteorological decision made in a country house in Hampshire on the morning of June 5, 1944. The pivot point is a man in a wet raincoat with a set of weather charts in his hand, which brings the story back to where it began. Back to Southwick House, back to Group Captain James Martin Stagg, standing before the Supreme Commander at 4:15 on the morning of June 5th, with the wind still blowing outside the windows and the rain still hitting the panes, and the forecast in his hand that said, against the appearance of the sky, against the evidence of the storm still raging over the Channel, that a break was coming, a narrow break. 36 hours, perhaps. Not enough for confidence, enough perhaps for the operation. Eisenhower listened. He asked his questions. He looked around the table at the men whose armies and fleets and air forces were about to be committed. He said, according to the accounts of those present, some version of the words, "I am quite positive we must give the order." and the order went out. And 5,000 ships that had turned back into the teeth of the previous day's gale turned again, and set their bows south, and crossed the channel through a sea that was still rough, but no longer impossible, under a sky that was still overcast but no longer sealed against the aircraft that had to fly. They landed on the morning of June 6th. They took their beaches, they took their casualties, they dug in. They pushed inland, they fought through the hedgerows and paid the price the hedgerows demanded. And on the 13th day after their landing, on the morning of June 19th, the storm that no one had forecast arrived over the channel and stayed for 3 days. It found Mulberry A off Omaha, and it broke it. It found Mulberry B off Arromanches, and it damaged it. It found 800 vessels at anchor off the beaches, and it hurled them onto shore or sank them where they lay. It killed men who had already survived the landing. It flooded fighting positions. It cut supply for 3 days that were already dangerous, and the beachhead held. It held because the men were ashore. It held because the perimeter had been pushed inland far enough to absorb the loss. It held because engineers could work behind the lines, sheltered from the worst of the wind, salvaging what could be salvaged from the wreckage of Mulberry A, and hauling it, caisson by caisson, pontoon by pontoon, section by section, over to Mulberry B. What emerged from those weeks of salvage was not the harbour the planners had designed. It was a hybrid. A British harbour reinforced with American parts, patched and braced and improvised, but functional. It became known, informally at first and then permanently, as Port Winston. And for 8 months from the aftermath of the storm through the autumn and into the winter of 1944 and beyond, it did the work of 2 harbours. It landed something on the order of 6,765 tons of supplies a day, on average, through weather that was often foul and occasionally worse. Over its full working life, it landed roughly 2.5 million troops, 500,000 vehicles, and 4 million tons of material. It sustained the campaign in northwest Europe until the port of Antwerp was captured and cleared and opened to Allied shipping, at which point the great expedient of the Mulberry programme was allowed to close down, its purpose served. The engineering scale of what those harbours represented is worth pausing on. 144,000 tons of concrete, 105,000 tons of steel, 85,000 tons of ballast, 6 miles of floating steel roadway, all of it designed and built and tested in secret, all of it towed across the English Channel under its own tugs, all of it assembled off 2 invaded beaches under the guns of 2 frontline armies. The concept alone stands as one of the great engineering achievements of the 20th century. That half of it was destroyed by weather within 2 weeks of assembly, and the other half survived only because a fortunate combination of geography and geometry gave it partial shelter, is the measure of how narrow the whole enterprise was, which is the measure in turn of the 13 days. 13 days, not a lucky margin, not an accident, not a gift of the weather, the product precisely of a forecast delivered under conditions of enormous uncertainty by a man who could not be sure he was right, and of a decision made under conditions of enormous responsibility by a general who could not be sure his forecaster was right, and of a fleet's willingness to sail again into a sea it had already once turned back from. 13 days that placed the invasion at the moment of maximum available surprise, 13 days that placed the storm at the moment when the beachhead could absorb it, 13 days that separated the fleet from the fate the alternative timeline has now traced in detail. There is a note in the historical record that Eisenhower sent to Stagg after the war when the shape of what had been decided in that room could be more clearly seen. It was a handwritten line, brief and characteristic. Stagg, it said, "Thanks, and thank the gods of war we went when we did," signed with the initials by which the general signed his personal correspondence, D.E., the gods of war. It is the phrase of a man who understood better than most how much of what happens in a great campaign is determined by things no commander controls: weather, tides, the angle of a sandbank offshore, the precise track of a low-pressure system moving down from Iceland. The distinction between a storm that arrives on the 13th day of a lodgment and a storm that arrives on the first day of a landing. These are not the products of generalship. They are the environment within which generalship must operate. But the decision to go, on the morning of June 5th, 1944, on the strength of a forecast that predicted a window no one could be certain existed, was not the work of the gods of war. It was the work of one meteorologist, one general, and the discipline of a staff system, that had trained itself to convert uncertainty into action. Everything that followed, the mulberry that survived, the beachhead that held, the campaign that swept eastward through the summer and autumn of 1944 and reached the German frontier before the year was out, the coordination with Bagration, the political survival of the coalition, the eventual conclusion of the war in Europe in the spring of the following year, flowed from that morning. The alternative timeline that this thought experiment has traced, in which the invasion is postponed and meets the storm at sea, is not a fantasy of what might have been. It is the shape of what was avoided. Postpone D-Day past June 6, 1944, and the next available window is June 19th. On June 19th, the worst Channel storm in decades arrives. That is not speculation. That is the calendar. That is the meteorological record. That is the fact against which the historical decision must be measured. Measured against it, the decision to go on June 6th stands as very possibly the most consequential 24-hour call of the entire war. Not because it won the war by itself. Nothing wins a war by itself. But because it placed the invasion inside the narrow gap of weather in which the invasion could succeed, and because the alternative, the only available alternative, was a fleet crossing a channel that would have destroyed it. The sea does what the sea does. The wind rises when the wind rises. The storm of June 19th arrived on its own schedule, driven by pressures and temperatures that no human command had any part in ordering. What men could decide, they decided. What weather could give, it gave. And in the narrow gap between the two, 13 days wide, no wider, the 20th century turned. Stagg lived until June 23rd, 1975. He died just short of his 75th birthday and just short of the 31st anniversary of the storm, whose absence on the morning of June 6th, 1944, had made everything that followed possible. He carried Eisenhower's note with him for the rest of his life. Thank the gods of war we went when we did. The gods of war in the end are only the weather, and the weather in the end is only what it is. What men do in the moments when the weather offers them a choice is the whole story.